Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's algebra class. Today we are going to continue with my Chapter 6 add-ons. We're going to learn one more property of exponents, which is extremely important. And again, I don't know why the book skipped it, but it did. So I wanted to teach you this because if you don't know this, it's very difficult to continue forward. So today we're going to talk about the division properties of exponents. And when you divide the same base, again, notice it's very similar to multiplication. You divide the same bases together, whether the bases are numbers or variables, simply keep the same base and this time subtract the exponents. Then simplify numerical values accordingly. So what does that mean? If I have a to the m over a to the n, I'm going to keep the base of a and I raise it to the power of m minus n. When I raise a quotient to a power, it's the same thing as raising a product to a power. I'm going to take this outside exponent, I'm going to multiply it to everything inside of the radical. So this would be a to the mp divided by a to the np. And how would you simplify that? A to the mp minus np. That's the division property. Now, I'm going to show you guys how to do it with the subtraction. But there's a much easier way that I came up with, and I think that you're really going to like it. I'm going to give you both ways, though, like always. I'm not telling you you have to do it my way. I just find that it's a lot easier. Let me explain both ways. X to the 8th over x to the 3rd. This is plain and simple. This is the easiest type you can have. Technically, what's happening here is this is x to the 8 minus 3, which equals x to the 5th power, correct? And that's in the numerator, right? Right? Okay, now, that's how you do it technically. But eventually we're going to get to parts where you have negative exponents in the numerator and the denominator, and you're going to have to subtract a negative, and that's going to cause problems. I know it is. So what I figured out was, check it out. How many x's do I have here at the top? How many do I have here? Ready? I'm going to blow you away. Can't I take 3 away from here and 3 away from here, leaving me with x to the 5th in the numerator? I'm done. Look at what I did, guys. All I did was cancel. How many x's do I have in the top? How many x's do I have in the bottom? If I take 3 x's from here, can't I take 3 x's from here, leaving me with x to the 5? Yes, you are subtracting, but without the subtraction. It's quicker. Do you see this, guys? Look, if you don't see that, think about it like this. X to the 8th is 1, 2, 3, 4, 5, 6, 7, 8 x's multiplied together. X cubed is 1, 2, 3 x's multiplied together. X divided by x cancels. X divided by x cancels. X divided by x cancels. What am I left with? X to the 5th. That's what I'm doing, but without expanding it. Yes? No, I did not say you always put the top number. No. To subtract, yes, it's always x to the 8th minus 3. Yes. Now, why do I have this trick? I'm going to show you right now. So this is x to the 5th. The technical way to do this is w to the 4th minus 7, right? It's this minus that, right? Which equals w to the negative 3, which equals 1 over w cubed. Does that sequence make sense? Okay. Now, let's look at Mr. Morrow's trick. How many w's do I have up here, my brothers? How many do I have down here? Pay attention. Can't I take 4 w's from here, leaving me with a 1, and 4 w's here, leaving me with w cubed? Isn't that the same and a lot quicker? I heard a few oh wows and I like that. Does that make sense? You promise? Okay, no? No, how do I get the 1? I took out w to the 4th. What's w to the 4th divided by w to the 4th? It's 1. Thank you, sir. Now, here we're just distributing. So this is going to distribute to every single exponent, period. So this is x to the negative 6 over y to the negative 12, which then I'm going to bring this guy up and this guy down. So I get y to the 12th over x to the 6. I cannot simplify that because they are not the same base. Does that make sense? Stays like that because I cannot simplify that any further, sir. 3x cubed divided by 2y to the 5th raised to the 3rd power. It's going to be 3 cubed x to the 9th over 2 cubed x to the 15th. So this is 27 x to the 9th. I'm sorry, that's not an x to the 15th, that's a y. Thank you, sir, for catching that. I appreciate that, sir. Thank you. So 27x to the 9th over 8y to the 15th. I cannot reduce anything from 27 and 8. X and y are not the same base. I'm done. Sir, what's 2 cubed? 2 times 2 times 2 is 8.
No.
Yes?
Oh, yes.
Yes, it is. 2 cubed is 8. Yes, it is. 2 times 2 is 4 times 2 is 8. Does that make sense, brothers? Thank you for your honesty, kid. Thank you. Takes guts. May I continue? Okay. Now, let's go ahead and practice some, okay? I got y to the 8th divided by y squared. You could go the traditional way and go y to the 8 minus 2, which equals y to the 6th. Or you could just start learning my trick. How many y's do I have in the numerator? How many do I have in the denominator? Let's take 2 from here. Let's take 2 from here. I'm left with y to the 6th. Done. B, h to the 5th over h to the negative 5th over h to the 4th. This is where it gets funky. Traditionally, you should do this. H to the negative 5th minus 4, which equals h to the negative 9th, which equals 1 over h to the 9th. That's the technical way to do it. I don't like that. First of all, whenever I have a negative exponent, what have I taught you to do? Bring it down. So immediately this is 1 over h to the 4th times h to the 5th, which equals 1 over h to the 9th. You didn't have to do any converting. Nice and easy. Are you guys seeing this? There's a lot of power here. Sir. Okay. Let's say it was h to the negative 5 over h to the negative 4. Well, this would become h to the 4th over h to the 5th. Get 4 of these by, 4 of these go by, and I have 1 over h. Great question. Thank you so much. Does that make sense, gentlemen? Promise? Okay, let me go ahead and... Yes? Yes? Okay. All right, here. Let's pay attention to this, guys. Let's pay attention. First of all, I always want to get rid of all the negatives. So let's rewrite this, okay? I've got x to the 5th. This guy goes up. Y to the 5th. W to the 7th over x cubed. This guy goes down. Y cubed. W to the 12th. All I did was change the negative exponents to positive. Does everyone see that? Okay, so now let's simplify. I got 3x's here, get rid of 3 from here, so I'm left with an x squared. Do you see that? I get rid of 3y's from the denominator, get 3 from the numerator, I'm left with y squared. Does everyone see that? I got 7y's in the numerator, get rid of 7y's in the denominator, I'm left with w to the 5th power in the denominator. Does everyone see that? Go ahead. Someone said wait, I'm here. What's up? Are you sure, my man? Everyone sees it. Cool. Thank you. Next. m to the 4th times n cubed over m to the negative 7 times n to the 9th. What do I do with this m to the negative 7 first? Bring it up. So I got m to the 7th, m to the 4th, n to the 3rd over n to the 9th. What's m to the 7th times m to the 4th? M to the 11th. Beautiful. I got 3 n's here. Take 3 from down here. And I got n over 6. Heck yeah. Well done, son. Is this making sense, my friends? Okay. Thank you, brothers. Let's continue. Let me actually move this down here. Okay. Let's expand this a little bit. I'm going to erase this answer. Okay. Now, I've got a exponent on the outside, so I got to distribute to everything. So this is 3 squared, which is 9. Y to the 6th, x to the 10th, over x to the 4th. I've got 4 x's down here. Take away 4 from the numerator. My answer will be 9. Y to the 6th, x to the 6th, over 1. How would it be 6y? 3 squared is 3 times 3, which is 9. Thank you for caring, sir. May I continue? No, you do not have to put the denominator of 1. I just showed that so you could see it's in the numerator, sir. Thank you, my brothers. Okay, next. Let's bring this down. Let's do this guy. Hey, this one is quite awesome because I've got a negative that I have to distribute. So this is c to the negative 6, a to the negative 12, b to the negative 15, over a to the 12, b to the 6th. What do I have to do with all those negative exponents? Bring them down. So all of these are going to go down. So what am I left with in the numerator? A 1. So I have the a to the 12th, that was the original. Then I bring down the c to the 6th. I bring down the a, bring down the b, and then I have the b that I had originally. So my answer is going to be 1 over a to the 24th. Good. B to the 21. B to the 21, 15 plus 6 is 21. And C to the 6. Does that make sense, gentlemen? The order does not matter. Because it's the commutative property. Okay, next. I've got a 5 on the outside, so I got to distribute that 5. So I got A to the 20, good job. B to the 15 over. Excellent. What do I got to do with this negative? Bring it up, bro. So I got A to the 20. Very good, son. A to the 45. B to the 15th. And that is over 1 because it's in the numerator. That was excellent, son. Well done, brother. Are you guys with me? Go ahead. That's why I asked if you're with me. Talk to me. Because A to the 20 times A to the 25, when I multiply the same base, I add the exponents. 20 plus 25 is 45. Does that make sense, son? Thank you, sir. Okay. Now, let's do this one. I've got to distribute that 3 to everything inside of the parentheses. So 2 cubed, x to the 6th, y to the 9th, over 3 cubed, x to the 12th, y to the negative 18th. What do I do with that negative exponent? Yes. So I've got 8, x to the 6th, y to the 9th, y to the 18th, over 27, x to the 12th. Does everyone see that? Everyone. Okay? 8 and 27, I cannot reduce that. However, I've got 6 x's up here. Take 6 x's from the denominator. I'm left with x to the 6 in the denominator. I don't have to do any guessing here. I write down exactly what I have left over. Y to the 9th times y to the 18th is y to the 27th. Why is it in the numerator? Because that's where it was from the beginning. You just follow suit. It's a lot easier than the whole subtracting thing, isn't it? Sir. Okay, no. Remember, there's 6 x's up here in the numerator. So take 6 away from the numerator. Take 6 from here, you're left with 6x's in the denominator. Does that make sense, son? Because you have 6 here, take 6 away from here, take 6 away from here, and I'm left with 6 in the denominator, sir. May I continue? You have now learned the law of exponents. All the laws. Multiplication. When I multiply the same base, I add the exponents. When I raise a power to a power, I distribute the outside exponent and multiply all the exponents by the outside exponent. Division. When I divide the same base, I subtract the exponents and keep the base. When I have a negative exponent in the numerator, I bring it down to the denominator to make it positive. When I have a negative exponent in the denominator, I bring it up to the numerator to make it positive. So basically, I reciprocate. I find the reciprocal when I go from numerator to denominator or denominator to numerator. I change the sign of the exponent. And last but not least, but very important, a to the 0 is 1. Anything to the 0 power is 1. Okay? Does that make sense, boys? Okay, let's just do a general overall practice. Leave all answers with positive exponents. X squared times x to the 5th, x to the 7th. That should have been a no-brainer. B. I've got a negative 1 that I've got to distribute. So I'm going to have negative 4 to the negative 1. X to the negative 8, and let me put that negative 4 in parentheses, over 2 to the negative 1, x to the negative 3. What do I have to do with all these negatives? These guys are going to go up. These guys are going to go down. So this is going to be 2x cubed over negative 4x to the 8th, which will equal negative 1/2. 3x is in the numerator. Take 3 away from the denominator. I'm left with x to the 5th in the denominator. Talk to me, please, my brothers. I reduced it. 2 goes into 2 one time. 2 goes into negative 2 times sir. Hence negative 1/2. You can reduce. Does that make sense? Thank you. Yes, sir. Come again? Where did I get that from? Right here, bro. Negative 4 to negative 1. I got to bring it down. Thank you, sir, for asking. May I continue, boys? Okay, I'm going to distribute a negative 2 here. So I got a to the negative 2, b to the negative 2, over 5 to the negative 2. Flip it. This is 5 squared over a squared, b squared. So that's 25 a squared, b squared. Yes? Yeah. Yeah, 5 squared, yeah, you got to do them. I'm never going to give you anything crazy. Like, I'm not going to give you 5 to the 26 or anything like that. Okay? All right, let's continue. Here I got 81 w to the 6, y to the 7th over. I got to distribute. Hold on, let me make sure that's not negative. That's not a negative, right? Yeah, no. Okay, so this is 3 squared, which is 9. W to the negative 4, y squared. What do I do with this negative? Bring it up. So what's 81 divided by 9? So I got 9. And then when I bring up this W4, that's going to become W to the 10th. 2 from down here, take 2 from up here, and I got y to the 5th over 1. Does that make sense? I didn't bring up the 9. 81 divided by 9 is 9. I brought up a W to the 4th. W to the 4th times W to the 6th, W to the 10th. Thank you for caring and asking. Does that make sense? Yes, good. I hope you find it easy. There's a few more here. You can do some of these on your own, but before I run out of time, Let me do the Mac Daddy, okay? Whoa, let me do this guy right here, okay? Check this out. I got to distribute this to everything. So this is 2 cubed, which is 8, x cubed, y to the 9th, z to the negative 6th, over x to the 12th, y to the 6th, z to the negative 9th. Does everyone see that? Times x to the negative 4, y to the negative 10, z to the negative 6, over 4 squared, which is 16, x to the 12th, y to the 6th, z to the negative 8. Now, a lot of people stress out here and freak out. Guys, don't we just have a multiplication here? Aren't we just multiplying basically two fractions? So, 8, and 16, that can cancel to 1/2. You guys with me? Hello? Numerator times numerator, denominator times denominator, right? So what's x to the 3rd times x to the negative 4th? X to the negative 1. Y to the 9th times y to the negative 10th? It's y to the negative 1. Z to the negative 6 times z to the negative 6? Z to the negative 12. Signs are the same, I had to keep the sign. Denominator, x to the 12th times x to the 12th is x to the 24th. Y to the 6 times y to the 6 is y to the 12th. Z to the negative 9 times z to the negative 17 is z to the negative 17. It was z to the 9 times z to the 8th. Negative 8, sorry. Now, what do? Flip them, guys. So this is going to give me my 1/2. This guy goes down. So this becomes an x to the 25th. This guy goes down. So this becomes y to the 13th. That's gone. And then this guy goes up, and this guy goes down. So this is z to the 17th over z to the 12th. Cancel 12 z's from here. Cancel 12 from here. My final answer is z to the 5th over 2x to the 25th, y to the 13th. That is the hardest thing you will see. And as you can see, it took time. But none of this was difficult, was it? Take your time, follow the rules. The homework is from 21 to 30. I posted it. Thank you. I hope you learned a lot. Have a great day.